All right, so today we are taking a look at 8.5 graphing intercept form. An intercept form is given as being y is equal to a times x minus p times x minus q. Or alternately, f of x is equal to a times x minus p times x minus q. The example that we're given is actually in that function notation. So we have f of x is equal to 2, that's our a, times x plus 1 and x minus 5. So we're going to go ahead and graph this thing, and we're going to graph it by finding the zeros of our graph. And our zero is where the function has an output of 0, or where y equals 0. So it's basically wherever your function is going to end up crossing this x-axis here, wherever it touches the x-axis, that's one of the zeros, because that's where our y value is equal to 0. So in order to figure out where our function here is equal to 0, we need to set it equal to 0. So we need to say 0 is equal to 2 times x plus 1 and 2 times x plus 5, x minus 5, excuse me. And actually solving for the zeros is really, really straightforward, which is pretty nice. And once you get a little bit of practice of it, you won't even have to solve them anymore. You'll just look at it and say, well, those are our zeros. So we have 0 is equal to x plus 1 and 0 is equal to x minus 5. And the reason why we're able to split this up is because if either one of these sets of parentheses ends up becoming a 0, it'll end up wiping everything else out because this is all multiplied together. The 2 has no impact whether or not either of these sets of parentheses ends up being 0. So we could just get to ignore it here. If we had a 2 sitting outside the parentheses here, we just end up dividing the 2 as the first step. And 0 divided by 2 is just 0. So we wouldn't even have to worry about it. So let's go ahead and solve. The first one, we need to subtract 1 from both sides. Opposite operation, plus 1. So we need to subtract 1, which gives us x equals -1. And on this one, we need to do the opposite operation, which is to add 5, which gives us x equals 5. Notice that as in the intercept form, as written up here, minus p in this example is minus -1, because minus -1 is the same as plus 1. And likewise, minus q, our q would just be 5, because it's 5 minus the q value, which is a positive 5. Essentially, when it's in intercept form, your solutions down here are just going to have the opposite sign of what is written in the intercept form. So it's really easy to just say, oh, this is -1, this is positive 5. But until you get comfortable with that, I do the steps here. In any event, that gives us our first 2 points, which are -1, 0 and 5, 0. And you might be saying, hold on a moment, where did you get the 0 for the y value? That was given. The 0 for the y value is, you always have a 0 when you're looking for the zeros. So you just need to solve the x's and it will give you the other half of the point. So our first point is going to be right here, and that's at -1, 0. And our second one is all the way over here, nearly off of the video screen at 5, 0. But the problem at this point is that we really need our vertex. And without our vertex, this graph, even if we found a third point, is just not going to look quite right. So we're going to go ahead and go through our first way of finding the vertex. And our first way of finding the vertex is actually to begin by finding our axis of symmetry. And that is by utilizing x is equal to -b over 2a. And this one should be something that's relatively familiar to you. And in truth, we're just going to use the same skills that we've already developed, just in a new application right here. So we need to start by distributing. So I'm going to go ahead and rewrite this down here. We have f of x is equal to 2 times x plus 1 and x minus 5. And I need to multiply x plus 1 times x minus 5, and then I'll worry about the 2 as the last step. So we have our 2. We first need to multiply x times the x minus 5. And then we need to multiply our plus 1 times our x minus 5 as well. Normally, when I did problems like this earlier, I would write them on 2 separate lines. But in this case here, I'm just going to write them on a single line. because we have that 2 hanging outside and I don't want to forget it. So we still have our 2. X times x is x squared. X times negative 5 is minus 5x. And then 1 times x is plus 1x. And 1 times negative 5 is negative 5. We then need to combine our like terms, which are just these middle ones here. We still have our x squared. Negative 5x plus 1x is minus 4x. And then we have minus 5. And finally, when we distribute the 2 through, which you can't see right now, when we distribute this 2 through, we get 2x squared. 2 times negative 4 is negative 8x. 2 times negative 5 is negative 10. So unfortunately, we had to do all this distribution work just so we can now find the axis of symmetry, aka the x value of our vertex. And we now know what our a, b, and c are. So in our equation, we can plug in our negative b, which is a negative 8. So we have negative 8 divided by 2 times our a, which is also a 2. Negative 8 makes positive 8. 2 times 2 is 4. 8 divided by 4 is 2. So the x value of our vertex, aka our axis of symmetry, is that x is equal to 2. But now we need to solve for the y value of our vertex. And I'm going to do that by plugging it into one of our equations. And I'm going to go ahead and plug it into this one because it's right there. So we have f of 2. That's because our x value is 2. And now I'm going to replace every one of my x's with that 2. All 2 of them. Okay, so our f of 2. All right, 2 times 2 to the second is 4. So this is 2 times 4. 2 times negative 8 is negative 16 minus 10. 2 times 4 is 8 minus 16 minus 10. That would give me f of 2 is equal to negative 18. Okay, so that means my vertex 2 and negative 18 would be 2 comma negative 18. Perfect. All right, let's go ahead and put our vertex on our graph, which unfortunately is not going to be super easy. It was 2, negative 18, so I have to go down here. 2, negative 4, negative 8, negative 12, negative 16. Okay, negative 18 is going to be right here. So this is my vertex, 2, negative 18. And now I just need to connect my points and we'll be done. Try and get something good looking here. Okay, that wasn't great. But you know, that's what happens when you freehand it. And we have successfully graphed our original intercept form, 2 times x plus 1 times x minus 5, using the zeros at negative 1 and 5, and then finding the vertex using x is equal to negative b over 2a. And in truth, we pretty much just used skills that we had already developed, and we just used them all here. And if you're comfortable with being able to graph from intercept form using this, then you can go ahead and stop the video right now, because I'm about to go into another way that you can graph this. And if you're satisfied with this, then you might want to stop because I don't want you to get confused. But if you want to learn more, then keep going. All right, let's go ahead and look at the alternate way that we could have found the vertex in this problem. So rather than do all this work, finding the axis of symmetry, plugging it in, all of this crap, we can skip the distribution and the axis of symmetry part and pretty much just go straight to the plugging in part. And the way we do this is we start with our original equation. So we have f of x is equal to 2 times x plus 1 times x minus 5. And let's go ahead and look at our graph a little bit so I can give you an idea of where we're going with this before I present the formula to you. So you're going to notice something a little bit peculiar here. So our points are at negative 1 and 5, and then our vertex had an x value at 2, so this right here. Well, if we count up from negative 1 is 1, 2, 3 units away from 2. And if we go from 5, 2 is 1, 2, 3 units from 5. 2 is equal distance from negative 1 and 5. And considering these 2 points are the same height on our parabola, that shouldn't come as a surprise because as I'm sure you remember, we have an axis of symmetry. And this axis of symmetry divides our parabola into two symmetric halves, in as much as I can draw a parabola. But it divides it into two halves, which are essentially mirror images of each other. So it makes sense that because the vertex is in the very middle of the parabola, it has to be an equal distance from 2 points that are at the same height and on opposite sides of the parabola. And what this means is that 100%, speaking accurately, the vertex, the x value of the vertex is just the average of the zeros. So earlier we discovered our zeros were at x equals -1 and x equals 5. Our average of those two is -1 plus 5 divided by the number of terms, which is 2, aka 4 divided by 2, x equals 2. Now the actual formula, the specific formula, is given as x is equal to p plus q divided by 2. And if we go back to our original equation, our p value is going to be the -1 here, because this is like minus -1 makes a +1. So that's why we have the -1. And then our q value is the p. The same thing, it's just the opposite of what appears here. So it's -1 and 5 divided by 2 ends up giving us x is equal to 2. And once you know that x is equal to 2, you have the x value of the vertex, aka the axis of symmetry, which means that you can then plug in 2 for x into your equation. So I plug in 2 here. This gives us f of 2 is equal to 2 times 3 times -3. Or, unsurprisingly, f of 2, once again, equals -18. And this gives us our vertex of 2, -18. And then you can go ahead and graph it as we did before. So this is a much faster way of solving this problem, and I think is probably the better and more conceptual way. But if you watch this and you're just totally confused as to how you're supposed to be doing this, then I would stick with the first method that was given. It's a little bit longer, but it builds upon the skills that we've been using really consistently. This one, it's not as useful for you to memorize the formula. It's a better idea to understand what it means for the parabola to be symmetric, and then from there figure out, oh, it's supposed to be the midpoint between my -1 and my 5, or my p and my q. Anyway, that's a quick alternative way for you to graph the parabola from the intercept form.